you for taking the time to basically be on the meetup. Unfortunately, we could not be we could not have this meetup face to face. I think everyone understands that. It would have been nice, but this basically gives us the chance to go into just beyond London and just beyond the UK. One of the presenters, Jeremy, he's from the US, so of course we could not have had that at such a short notice. We're going to try to keep the same format that everyone is familiar. We're going to have 3 presentations, 20 minutes each, followed by a panel at the end. Obviously, we're not in the same room, so with the questions, what I'll have to ask you is to basically send me a message. You can only send me a message on WebEx, so you'll have to find the chat button, and then if you have a question, feel free to send it to me, either at the end of each session or at the end when the panel will go. We do have some questions which came to us before we actually started the meeting, when people registered. Just to remind everyone, this is a recorded session. We're going to make this available, so make sure that you're all in agreement to be on this session while it's recorded. We also have the option to ask the question if you unmute yourself, but please stay on mute as long as you're not asking any questions. Obviously, we have quite a large audience. It's the first meetup that we're doing online, so please be kind with us. Don't pick up any rocks to throw at us. At the end, I have a SurveyMonkey survey which I'll be sending out to everyone to fill in. It's only 4 questions, so yeah, it'll probably take less than 10 seconds, but yeah, it would be good if you can fill this in. And I think that's pretty much it. We're going to try to follow the same format, of course. Of course, we're not going to be able to have the breakout sessions like we had when we had the meeting in person. But feel free to ask any questions and raise your hand if you want me to unmute you if you have any issues with WebEx. Perfect. We already have a few questions that are coming in. So as it was announced, we're going to keep the same order. Stuart Traynor, he's a systems engineer at Cisco. He's actually based in Glasgow, so quite happy that we are able to basically reach out to people not just in the London surroundings. I know people used to come to the meetup from even outside the UK. So it's quite good that now we can just join this session from the comfort of our own home. So I'm gonna pass the role to present to Stuart. Stuart has a presentation for Terraform. It's called Terraform 101. And Stuart, I'll let you present. And
thank you very much. Right, give me 2 seconds just to bring my screen up and we'll get started. So thanks everyone. Thanks for joining us this evening. I've wanted to kind of get involved with this community for quite a while. I've always been kind of not in London the weeks that it's been running and when it has been running, but Paul told me when I first met him that's not an excuse, but at least I'm here tonight and we can run through it. So what I've got is a bit of a kind of hot topic at the minute in network automation. I think it's the topic of Terraform as a configuration management tool. So I actually do quite a lot of work with Terraform. So what we're going to do is, this will be an introductory 101 session. If you've never seen Terraform before, this is probably going to be perfect for you, right at the right level. If you've used it before, you might find some of the content a little bit basic, but we'll try and kind of throw in some bits in there that might be interesting, and we'll do a demo. And also I've got some really good guides as well, in which everyone here should be able to go and get started. So just a quick introduction to me. Like I said, Stuart Traynor. I'm a systems engineer in Cisco. Been there 6 years. But my job's actually, I work in network automation, so that's my full-time job pretty much. So I'm a kind of work with network automation teams and kind of an evangelist for NetDevOps and network automation. So quite lucky to get to do a lot of this full-time. Just in terms of an agenda, what we're going to do today, we're literally going to cover what is Terraform, starting at the very basic level, what is it used for and how can you use it. We'll then cover the fundamentals. So if you've looked at Terraform and you've maybe seen it before, you might have heard of things like state, config, and the kind of workflow. We're going to cover all that at like a really good level, just so everyone's kind of at the same level. Also, a lot of discussion now is around Terraform and Ansible. How do they compare? What should I be using? I've seen a Packet Pushers podcast of 40 minutes of discussion on that the other day. So like we're not going to do all of that today, but we'll at least give everyone an idea of when they see Terraform, when they see Ansible, they can kind of then start to kind of understand when one might be better than the other, and what's the kind of differences. I'm assuming most people here have used Ansible, so we won't cover that in any detail. We'll just stick to Terraform. And then what we'll do is I'm going to do a demo and then show everyone how to get hands-on and how they can actually start to use this. So just for people that have never seen Terraform before, Terraform is, and started off, it was built by a company called HashiCorp. Completely open source, but it started off as a multi-cloud provisioning tool. So there's a couple of use cases that they talk about with Terraform, but really Terraform, and you'll hear the concept of providers. When Terraform was first kind of built, it was all around how do you provision resources and infrastructure in the clouds. So AWS, Azure, GCP, they were all the providers, and all the initial work was done by HashiCorp. What you're now starting to see is Terraform actually being used to provision resources, not just in the cloud, but also in on-premise, and the network, and security, and pretty much most of infrastructure. We'll talk about providers in a little minute, but there's almost like 200 providers now, I think. The main use case for Terraform is infrastructure as code. What you can do with Terraform is you have something called a config file, which you'll see here. You define that config file and what you want all your infrastructure to look like, and Terraform will go out and talk to all the different environments and basically provision that infrastructure, provision those resources. And it's very hard, that's what it's doing. If you maybe Terraform's used a lot by cloud and DevOps teams, probably less so by networking and classic infrastructure. But you see it a lot, and you definitely hear it being heard about in the cloud teams. But we're starting to see that now seep into the network. And definitely as the network meets the cloud, I think it's becoming more and more popular. So you'll see a couple of use cases here for Terraform. We're going to cover the infrastructure as code. So how you can actually start to define your infrastructure as code and have Terraform go out and do that and do that provisioning. There's also two other use cases here you'll see. So the self-service provisioning, that's because Terraform and HashiCorp and their tools are used a lot by developers. So it's all about how you can make things self-service. And then you'll also see multi-cloud, and that's just where Terraform came from. It came from being used around how you can provision resources across the clouds. We won't focus on those two tonight, and we'll just cover mainly infrastructure as code. So the biggest thing, if you take one thing away and what you want to understand Terraform, is you need to understand the config file. And that's actually what provides the infrastructure as code element here. So what you do is, in the start to every Terraform deployment, is you have a config file. And that config file actually will say what resources I want. So you can see here on that right-hand side, it's actually quite easy to read. It's almost in English. But it says resource, AWS Elastic Load Balancer, and then it kind of defines some properties of that. And then it also says resource AWS instance or app, and it's defining five Amazon virtual machines in Amazon. They should be T1 micro, and they should be a certain AMI. So that is what a config file looks like. And what Terraform does is it goes and takes that config file and then goes in and provisions it. We'll go in more into depth and how that might look in a networking environment. But at the key, you've got this idea of infrastructure as code, and the config file is a massive part of it. The other thing to really know about Terraform when it's used is it's all about workflows. It's not about the underlying technology, really. You could really using anything under it, but the real concept is this idea of workflows. So when you provision a workflow, it's always the exact same kind of workflow. You have a config, what then happens is you then do something called like a plan and then apply. So you're planning to say, well, what am I going to add? And Terraform's then saying, well, I'm going to add this many resources, this many virtual machines, this many networks. And then you do an apply. And the apply basically takes what your plan is and goes in and acts that. And then because we have this kind of idea of infrastructure that's kind of can be tore up or tore down, because like I said, this kind of the idea of Terraform is it's used in the cloud where workloads aren't kind of, they're in there and they're there for forever. They can be torn up and torn down. So Terraform also has the idea of a destroy. Now for networking, that's probably less, we don't think about that, how we're tearing down things, but the idea of being able to destroy and tear down your infrastructure is just as important in Terraform as being able to go out and deploy. You'll see here, I mean, there's different ways you can use Terraform. One is the CLI, so you can just do, and I'll show you that. We'll go in and we'll define, we'll say, right, I want to go and do a Terraform plan, Terraform apply, and go out and provision the infrastructure. But you can also use tools like Terraform Cloud and Terraform Enterprise, which provides a GUI, like you see here, where when changes are made, they're then going to push down. So that's the idea of Terraform. You've got this idea of workflows, and just remember that workflow, because it will always pop up. If you kind of understand that workflow, you start to understand what's going on. I said I'd mention this as well. We have the concept of providers. So the idea of the workflow is very important, because what it starts to do is you don't really need to worry what sits under it. Obviously that what sits under it is your own infrastructure, but what then happens is the providers can abstract a lot of complexity away. So you don't need to understand about how I'm going to configure this individual resource, because the providers will handle that, and you'll see providers there. I actually can go into the Terraform site. You can look into the providers. If we go into, for example, networking here, you'll see multiple Cisco ones, and probably a lot of other stuff that you use in your own environment. There's ones for Cisco ASA, there's ones for ACI, and whatever, and we'll show some of them as well. But you've got pretty much providers for I'd say if you've got infrastructure out there deployed today, you're going to have providers for it. It just really, you just need to kind of have a look. And we'll put these links in as well where you can see. And once you go in, you then got, for example, you can then go and see, well, exactly how do I go and use this? How do I go and define, for example, what my infrastructure should look like? And we'll go and we'll show that in a second. So let's start getting into a little bit of detail. The first thing you need to define, also, as I mentioned, was a Terraform config file. Now, the config file is just a text file. It's written in HashiCorp's own configuration language. It's called HCL. I think it can be written in JSON as well, but HCL is kind of their own kind of domain-specific language. As long as it's a text file, it's in HCL, HashiCorp configuration language, and it has an extension of .tf. It will 100% be it'll be a valid configuration file, and you can use it. It can be one file, or it could be 10, 15, 20, 100. You can split these files into multiple different ways, and depending on how you want to run your data center. And then again, you can have, as I mentioned, you can have multiple files there, but you can also have things like variables. So you can see here I've actually split, this is the config file we'll use for the demo later on, but it's got a couple of really basic kind of principles. We define what provider we're going to use. In my example, we're going to use ACI, but that could be, and for people that aren't familiar with ACI, ACI is Cisco's data center networking technology. ACI, we define what the provider is and the credentials we want to use. Obviously in production, this would be hidden. We can then define specific variables. So if we've got variables we want to use, we can define them. And then we go out and define our resources. And these resources are defined within the documentation. But I can, for example, say, well, I want a tenant, I want a VRF, I want a load balancer, I want, for example, a firewall rule. You really, the resources are defined within the documentation, and you just put them in this file. Once you put them in this file, the rest is then covered by Terraform and HashiCorp. Another thing to do is you can have multiple different providers in one file. So if I wanted to, for example, configure my network and my cloud infrastructure and my VMware infrastructure and whatever in one file, I could do that. And you could go and out to all these different 4 different systems and go and do that. You're really just limited in terms of how you want to lay out your files and how you're going to manage them. That's the key thing. Because you have one config file, and obviously you have to share that between teams and how you do things. Typically, this config file would be stored in something like a version control system, GitHub, GitLab, etc. One of the biggest things you need to understand within Terraform is it has a concept of state. So what happens is every time you go to run the config file, Terraform checks its state, and that state actually tells you what resources I've got out at the minute. So let's say I had a state file, and in that state file I had my tenant, my VRF, and an app configured. If I was to, for example, add in another tenant in my config file, the config does a diff to the state of the state file, and then we'll actually work out what needs to be deployed. So it's not going to go and do a full deploy and say, right, we need to go and deploy all these resources. It's going to check what's in that state file before it goes out and does it. So this is where Terraform probably differs from some other automation tools and some other configuration management tools, where it keeps state natively. If you do this in Ansible, if you do this in something else, you have to maybe keep the state by using another tool, and you might want to use something like NetBox, etc. This is using state and keeping state absolutely natively, and that's why Terraform is kind of becoming increasingly popular, because it solves a lot of these problems around how you actually keep network state. Also brings in challenges because it becomes really difficult to manage when you get into large environments. If you're running an environment where you've maybe 10, 15 different people working on the same config file and working from the same state, how do you start to make that? So you can have things like remote state where you share the state in a certain like an S3 bucket, or Terraform Cloud tries to solve some of these issues. So just understand within Terraform it's got state, and the config is always checking against the state to see what it needs to go and build up. We're going to show the Terraform. See, in fact, what we'll actually go and do now is we'll do a demo of Terraform, and we'll actually show how Terraform can be used to go and build up infrastructure. So what I'm going to show here today is a really basic guide, and we're just going to go through this guide, and actually it's got some examples that you can run through. I've got this in my GitHub, and I'm going to post this in the chat as soon as I'm done, and it's in these slides as well here. So what I'm about to do, you can run through at your own pace, you can test it out, you can try it, and you can actually go and get hands-on yourself. You can reserve the infrastructure as well, and you can do everything that we're going to do. But just know that this demo you can run through at your own pace and do it. So what we're going to do here is I've got a really basic ACI instance, right? I've just spun this up. It's completely blank. There's nothing on it really apart from the default. And what I'm going to do is I'm going to have a Terraform state file, which I've actually got here in my GitHub. And this Terraform state file will go out and define everything that I want to go and configure on this ACI instance. So it's going to go and log in, it's going to go and do build out the tenants, build out the VRFs, build out bridge domains, build out subnets, build out application, everything, all this kind of stuff that you could do kind of manually, but it would take time. It would you're prone to kind of manual error. You could fat finger something and put something in wrong. But we're going to do a fair amount of config, and what we're going to do is we're going to completely automate that. So we're going to create, I think here's about 25 resources we're going to go out and build here. And what I've got here is a completely blank version of ACI. So I'm just going to show you exactly how this would work. Just make my font a little bit bigger here. Hopefully everyone can see that. And here I've got my config file. It's stored locally on my machine. You can see it there. I'll just clear that here. And what I'm going to do is I'm going to do a Terraform init. And what Terraform init does is Terraform init goes out and installs all the providers that it needs. So for example, if I'm using an ACI provider, this will go out and install it. It will also look at my config file and tell me if I've got any expressions that are maybe depreciated, but we can still use it, so that's fine. But it should maybe say I should maybe look at maybe redoing that and maybe kind of updating this config file. But this is going to go and just make sure that Terraform's all installed and all working and ready to go. And it is. Then what we'll do is we'll do a Terraform plan. And this Terraform plan will go out and it will just look and see if there's a state file. Now I don't have a state file, so what it's going to do is it's just going to go and create everything in that config file. So it sees here there's 25 resources to add, nothing to change, and nothing to destroy. So it's going to go and add all the resources I've defined in my config file, nice and easy. And what we'll now do is we'll do a Terraform apply. And that Terraform apply will take that plan and it will now enact it. So it's just saying that do I definitely want to do this? I'm just going to say yes. And it will now go out and it will create all these. And you'll see that going through pretty quickly. Now, I never showed you before that there was nothing on this, so you'll have to trust me. But what you've seen here is actually, if I go in here, it's went and created that tenant, it's went and created all the infrastructure under it, all the VRFs, all the application groups, all the bridge domains, and it went out and created all the resources that's needed. And I honestly, go and try this yourself. This demo is completely, I mean, you can go and clone this onto your own machine, install Terraform, and you'll be up and running pretty quickly. And again, the config file's there. You can go and change it, and you can tweak it to whatever you want to do. And listen, if that config file gets you started and you want to go and use other providers or whatever you've got in your own infrastructure, you can go and that will probably provide you a really good starting point. So that was really the concept there, was just to show how we can start to use Terraform to go and deploy. What I also did say, we can also use Terraform to destroy, and that's one of these kind of things. Is we can rip down infrastructure as quickly as we build it. So what I can actually go and do is I can do a Terraform. In fact, before I do that, what you now see also here is there's a Terraform.tf state, and that now is my state file. So I could go and view that. It's just a big JSON file, but that now actually tells me what resources I've got and what resources have been configured. So this is now Terraform trying to keep a track and a track of my infrastructure and the state. So I could actually do a Terraform. Is it? What is the command again? Show, I think. There's a command where I can actually see my state. Yeah, it's Terraform state. Sorry. Show, and I can see all the resources that I've actually got configured as a list. Yeah, there we go. It's Terraform state list, and I can actually see all the resources. Now, what I'm going to do is I'm going to put in a Terraform destroy, and I'm now going to destroy these resources. Now, this is just also a demo. Probably wouldn't do this, but it's that concept of I can tear infrastructure down as quickly as I put it up within Terraform. And that's kind of one of these ideas. It's very much in terms of in the kind of cloud model, where resources are only there for maybe a period of time and only going to be used for a period of time. It's going to say that I really want to destroy all resources. I'll say yes, and as quickly as I've done that, if I now go in and if I go back into my tenants within ACI, you'll see there, I go into all tenants, you'll see there that the Terraform tenant that I created is now being completely destroyed and gone, and there's not a trace of it. So hopefully that gives you an idea of kind of what Terraform is, at least. If you're hearing about it and you're kind of it's been mentioned a lot now, and it's kind of a hot topic. Hopefully that gives you an idea of kind of what Terraform is and how it can be used and how it's different. I wanted to cover one last point before I kind of tie up this session, and it was just a bit of a comparison with Ansible, and it was maybe just to kind of to go through it. I think one of the things you see with Ansible is by default is stateless, and I mentioned this earlier on. You're pushing it at the intent of a playbook, you're pushing it at the intent of something, and it's running and it's doing exactly what you want. Now with Terraform, it's looking at a state, it's keeping a state of the network, and it's saying, well, or state of the infrastructure, I should say, and it's making sure that config that you've defined it matches that state. So it's less kind of declarative as Ansible, where you're saying, I want this to go and do exactly what it's want. It's more imperative. It says, well, listen, I'm always going to go and check that this is the way it's working. I'd say, as it stands today, Ansible probably still has the leg up on Terraform in terms of network automation, particularly where a lot of the network automation is still doing very much CLI based. We're logging in with SSH and we're pushing out config. I think what you're starting to see, Terraform is very much more focused to cloud automation, but there's definitely a push towards when there's native APIs. I think Terraform, and when there's this concept of resources, Terraform works really well when there's resources and the network's kind of slightly abstracted. It doesn't work well when we're pushing down just config to a device. I don't think it works. But when you've got this kind of concept of resources where the network's maybe slightly abstracted and we're not looking at individual switch port commands, I think Terraform works really well. Just from a kind of technical level, is obviously within Ansible, it's written in Python, and you define the playbooks in YAML. Terraform differs kind of slightly. It's written in Go. So if you want to write a provider for Terraform, it's going to be written in Go, and you're probably going to need to get pretty good in Go to start to be able to write it. Doesn't mean to use it you don't need to be good in Go, but to at least build providers. There are Python SDKs, but I don't see them being used very often. And again, yeah, you're defining config in HashiCorp configuration language, which is not difficult to get your head around, but just another one that's maybe you're used to YAML. But I think there's definitely, I think we see more and more of a place for Terraform the more we look towards automating on APIs and top of networks and where the network becomes slightly more abstracted. I still think Ansible has a leg up just in terms of the sheer amount of modules and the sheer amount of support you can do. So hopefully that provides a really, really quick overview. I think that was 20 minutes. So I'll quickly just summarize and just say, get hands-on. I've put a link to the guide here. And again, if you do use the Terraform providers and you've got any kind of limitations, and if there's any gaps, feel free to drop me a shout as well, because that's something I'd be quite keen in and try to understand. And I'll leave it there.
Perfect. Thank you, Stuart. That was really, really useful. And I like the destroy at the end. You don't just create things and then if something doesn't work, yeah, it just took a few seconds to do the same thing, but yeah, just to destroy it. So I think you were right, bang on with the time. I think we only have time to maybe take a couple of questions, and maybe we can ask some questions at the end, so we don't run over. If you want, you can post the question in the chat and I can read it, or you can unmute yourself, ask the question, and then mute yourself again. But I think we have a question from Daniel. Do you want to unmute yourself and ask the question? Daniel Petrov.
Hey, hi guys. Yeah, thank you for that. Just a very quick one. I didn't quite understand in terms of a state. When you define the state in that TF file, is that like every time you need to add on something, you just go to that file and that define the state of that's maybe the second question. What is that defined in the state of? How do you define the scope of that file?
Yeah, so it's the config file that you would edit. So you edit the config file, and that's one of the issues is they can get quite large, but you can split them down and you can kind of manage it into different teams. So yeah, you'd edit that, and then anything you'd have resources to add, you just go and edit that state, and that would be you. So as you're defining infrastructure properly as code, you're really trying to discourage people making manual change, because what then happens is when that change is then made, it's then pushed into the state. So Terraform actually can't track changes that are made outside as well. I should have probably mentioned that at the start. So it's literally that state is being made from the config file, and that's what you're adding to, and that's what you're changing.
Okay, just a follow-up, if I may, very quickly. In this particular example, you used the Cisco ACI, which pretty much the whole management is concentrated through the APIC. What if you have like a standalone network with like 150 devices? How does Terraform operate on that field? Do you need to in that particular case, do you define the network in one file again somehow, or is it like?
I think this is, and again, like, listen, I wasn't coming on to say this tool's perfect. This is one of the limitations of Terraform as well, where you can have this kind of concept of orphan configs if you're not managing fully through Terraform, and that's why I think it's probably not perfect for network automation. And it's probably sometimes at the minute, as it stands, because when you're pushing down, for example, you need to be managing completely, or you will have this kind of orphan config that Terraform won't know about. So you've raised a good point there that I didn't actually cover in the main presentation, but it was a 101. But if we can maybe go into detail, and we can cover that. But yeah, and I don't think it's probably good for managing standalone networks where there's no controller. It would probably work best for that, because how does it go out and manage all these different 150 devices? That's where Ansible's really good, because it actually can do SSH to multiple devices and do things like concurrency.
I got it. Thank you. Thanks very much.
Perfect. Thank you. And we have Simon Hart that wants to ask a question. Go for it, Simon.
Hi, Stuart. Yeah. Can it revert state? So what I mean is, if somebody goes into APIC and adds a tenant, can it check and then revert state using the state file?
So that's kind of on the last point of you can have this orphan config. There's a new part of Terraform being added a lot called Terraform import, which I've not had the chance to look into, but you can look into importing config that's made outside and bring it in and then manage it through the state. I think that's provider specific though, and I don't know how many providers are supporting that now, but it can be done. It's just it's being added like recently, and it's been developed kind of gradually, because it's quite a difficult challenge. Is how do I manage the stuff that I don't know about and is defined outside my state?
Okay.
Good question.
Perfect. Thanks for that. Thanks, Simon. Okay, so we'll have to move on to the next presentations. Thank you, Stuart. I think we'll be able to take more questions at the end, but we'll try to stick with the timings. Next in line is Catalin. So Catalin is a network engineer focused on service provider networks. He's the author of LnetD. So Catalin, I'll let you give an intro about yourself, and I'll let you present. Go for it.
Thanks, Paul. If you can mind giving me the share option, that would be great.
All yours.
Perfect. So let me expected, and can just give me a confirmation you see my screen. That will be great.
Yeah, see it.
Oh, perfect. Thank you. So hi guys, my name is Catalin. I'm a developer for LnetD, which is a network discovery tool, open sourced, and that's what we are going overview and hopefully a demo that will run without issues. So just a quick intro about myself. I'm a network engineer, as I mentioned. I'm more focused on service providers, small, big. I work on a couple of them. The reason for me creating LnetD came when usually I join companies, not all of them have diagrams, or the ones that they have are not accessible for me in day one. Some of them have network modeling tools, some don't. So I thought, let's see how it goes. Maybe we can build one and open source, and everybody can leverage that in the future. So next time you join a new company and you want to see the topology, you know what to look at. So it started a while ago, and I started with just building a ISIS speaker, and then it grew into support, getting the topology from Junipers, then XRs. Then at some point I managed to get a hold of a Nokia device and managed to get that information as well. And recently, the one that covers everything is just pure BGPLS using ENMS, and it's built on Python. And then for diagrams, it has D3GS. And initially, in the web application, I had a modeling tool, but then I switched, and I have a separate one now that will in the demo. So as I mentioned, it started in 2017, just a blank HTML page, and then it grew, and now it's in a state where it looks decent and it's useful for day to day. So how does it work? So it's netconf, and it parses the ISIS database and takes source, target, and local and remote IP and puts that into a database. So at the moment, the database is SQLite. It doesn't need to be a performance one. Similar for XR, and similar for Nokia devices. It goes and takes that information. BGPLS is a different thing, and it's not covered here, but it's supported for any other vendor that is not one of the three that I mentioned. So what happens after we get the database and we get a graph of the network? Of course, how the network is connected is to get more useful information out of it. So the most useful information I find is that the traffic level, how much traffic does it flow through the links, and for that, you just enrich the graph model with some extra information, and the extra information is, of course, capacity, errors if you have, and the utilization and out utilization. And that's done with SNMP by default, some telemetry, but by default it's SNMP, and SNMP using InfluxDB as a time database, and whatever client telegraph in this particular case. After all that's done, you get a view of your network that you discovered, and it supports parallel link, of course, and it supports a weather. Each link has their own utilization and display, and you can click on the link and get that information. So that's the main concept, and that's the basic idea. But of course, once you get the graph of the network, then you have the need to play around and just go into little in depth and try to understand how the traffic flows into the network. So there is an SPF algorithm that can calculate the shorter distance between two nodes, and that's what's displayed here. Other features that are part of the tool that I want to cover in today's demo, but just to let you know, so it's you can get utilization between POPs. Now that you know the graph of the network, then you can easily extrapolate and say how much traffic I get from one POP and capacity between links. You can also map other features like NetFlow. So we support ingesting NetFlow configuration and building a Shanky diagram if you want to see how your traffic comes into the network and where it exits based on IGP information. So it gets that and correlates the NetFlow data with IGP information and provides. The other feature that was mostly requested and I had in mind when I started the tool is to have a replacement for Cacti weather map. So that's in the tool at the moment as well. You can create a static view of your external peers in this case, and get in and out utilization, and of course do some reporting around that. Device inventory is just another module that goes into the network and parses chassis information, interface information, and provides displays that into a nice graph there. BGP information, it's also important. It's nice to have the IGP view. It's good to understand how your BGP topology is. So the tool supports discovery on Juniper and Cisco, using, of course, your I or eBGP connection in a D3GS diagram. So I mentioned the what-if scenario, and that's a critical component. After you discover the network, you might start wondering what happens if a link fails, or what happens if the traffic surpasses the link capacity. How do you solve that problem, and how do you go about making sure that you have shelf tools, usually very expensive, like Carridon, Wandle, or Packet Design, that can provide that information. And there are a couple of open source tools. I think there are 2 open source tools that can do that as well. So one of them is LnetD Qt, which is a Python Qt application that will go into detail today in the demo. But what it does, it allows you to first import some demands. So put some demands onto your network. You import the topology from the web application. You have that view, and then you can import some demands from either Cantic if you use Cantic, or PMACT if you use that. You get the NetFlow demands from topology, change the metric, and see how the traffic looks like after the changes that you've done. Couple of deployments, the ones that were allowed me to share their overview. So we have 3 examples here. It's a UK fiber to the home provider, an UK mobile provider operator, and a hosting provider, global hosting provider, how their network looks like after discovered by LnetD. So it gives you just a short overview of IGP routers, prefixes, so on, and the network distribution. Quickly, so hopefully we can get the demo working and nothing breaks. So I have a small topology in ifng and instance of LNet, which at the moment has nothing discovered. So the IGP topology, it's blank. We'll go ahead and try to discover this topology. And before I do that, and hopefully everything still works here, I just want to run some iperf between nodes so we can get traffic in. So as I mentioned, the discovery can be done via netconf, and in this demo, I'm using a Juniper box, and we'll go ahead and discover the links. It will go to the device, parse the IGP information, then go to InfluxDB and enrich that information with some metrics like utilization and capacity. Once that's done, if we go to information, web application in the IGP topology, we should have the topology, the network topology. It supports dragging nodes around, zoom in and zoom out. You can arrange the topology in a manner that mostly suits your network, and I will try to do that because it's and saving that topology. So next time I'm going into the IGP topology, that information it's there. So I mentioned you can click on the link to have a weather map information. So if I to have the traffic information for this particular link, you can see it gives me the 24 hours and the time that I tested some of the features today are shown there. This is a live view and it's blue, so it's really not that much traffic going through that. So I will run the discovery again to get the accurate information when iperf runs. So you can see I tested today at around 1 o'clock just to make sure everything works. And I have that information in place. So this one will discover the network first and foremost. And then after discovery, you can get traffic utilization. Of course, this is the node view, and you can have some other views as well. I will not go through all of them, but some of them are the nested topology, which can display your network based on POPs, countries, or whatever you would like. So instead of showing individual routers in each country, you see just how the network connects at the high level country view. Again, you can save that, and a link, you can click on a link between two countries and it will show you that that utilization. So you can see between France and Kenya, for example, I have two links in the nested topology. There is another view that just goes away and aggregates that. So instead of having France to Germany as a two link, France to Kenya as a two link, then it just has one link which has the capacity combined. And again, you can hopefully click, once you zoom in, you can click on that. So you see the capacity now, it's 20 megs, where in each having a 10 meg connection in this one. Some other features, and I will urge you to go to look at the demo because we don't have enough time here to cover all. But you can filter topology. So if you can imagine having a big network, you can just try to filter per country or just country to country. So for example, here I'm just filtering everything in UK and everything that connects to France. For this small topology is not very useful, but if you go to a view that has, for example, a closed topology, and you want to find how nodes connect to each other in this type of topology, it will be really hard to do if you don't have a filter button. So again, probably filter if we want to see a specific spine as an example. So spine 4, how it connects and how it connects to other super spines, for example. So you get that filter in this tab. The other thing that I want to cover here is just another view of your IGP topology, which doesn't look at the utilization, but rather looks at the errors on the interface. So if you have a need to understand if you have an interface that in your IGP that it's erroring, then you can use that. So I will go ahead and rediscover the network now. Hopefully the bandwidth ran enough for you to see the utilization. We'll go ahead, and usually this is done in a cron tab. You can discover every 5 minutes or discovery ran its course, and hopefully now when I look back at well, hopefully, but not quite yet there, I should have seen some traffic utilization, and it's probably there. I just needed to wait a couple of more minutes. So we'll come back to that after I do the what if scenario, because I think this one takes. The web part of the demo. So now, as I mentioned, it's always nice to have an understanding what if something breaks into the network. So for that one, there is a complementary tool which is called LnetQT, the lack of a better name. So what this tool does is just a modeling tool for your network. It provides. You can import the topology as it is in the web application. So as you can see, I have the same topology as I have in the web one. And if I change something in the web version and I save the topology, if I go back, I import it again. And hopefully it doesn't freeze out. Yep. So this node has moved to there. So I wanted to go over a small what if scenario today with you, and for that we'll switch to this application. So as you can see, we have a small network, and it has 3 countries. It's UK here, France in the middle, and then we have Kenya with a couple of routers. And what we want to find out is what if we put some traffic onto the network. So we'll go ahead and add some demands, and the links, as I mentioned, between cities within the country, it's 100 meg. Outside is 10 megs, just for the demo purpose. You can see how much capacity we have and what's the metric of the link. So we'll go ahead and from this node to this node add some traffic, and we'll go ahead and add 4 meg of traffic. That should be more than enough for this demo. So 4 meg of traffic will come from here, going through here, and you know what? We'll add 4 more just to have some nice colors. So at the moment, our network has an 8 meg demand. And you can see where the traffic flows and how the link is utilized. So you see this one, it's 80% because it's a 10 meg link. And right off the bat, you can see some of the strange behavior. So you can see, I zoom in here a little, just for you to have an idea. You see this link between PE2 and the other PE3 is only one of them is used. So that's because somebody probably forgot to change the metric. You can go ahead and change metric that the traffic gets redistributed automatically. So I will change it on the other side as well. So now you have an idea that this link is 80%. So you go ahead and try to figure out how can I solve this problem. and what can I do to alleviate. So there are multiple options where you can solve increasing capacity or doing some other tweaks. And to add to that, maybe we can add some traffic on the reverse. So we'll go from this router, and this time we'll go to this E5 in London, and we'll just add 15 megs. The reason I want to do this is because one of the links, it will get tested. So 150 utilization in the model. So you need to fix this information as well. So how do you go about and fix it? You can, as I mentioned, add more capacity, but what we will try to do today is just try to solve it by adding a new router in France, for example. And from there, we can just and just to have enough redundancy, we'll add it to UK. So you can see now traffic has Swift and switch, and I want to keep the same capacities. So it's 10 megs between countries. And see how that affects the traffic. So you see now we have that that traffic which has shifted from this node to the other node. So nothing really happened in terms of solving our issue, but you can go ahead and increase this capacity and add another link or create some other type of method. So either add capacity on this one. The other thing that, yep.
No, just to let you know that we will have maybe a couple of minutes left.
Yeah, sure. I'm just about to finish. So the other thing that the tool tries to solve is scenarios. So of course, some of the failure scenarios are pretty easy to understand. What happens if this link goes down, right? It's no-brainer. If you fail that, to isolate the traffic. So it will tell you that there are traffic demands in the model that can't be deployed, and you have the choice to go about and say, maybe I want to link these two nodes together. So that way my traffic still flows. So it's just another tool that you can use in your tool set to understand how traffic flows and into the network, and how to recover and how to improve the redundancy of the network. So the last one, hopefully by now the links were, and we have enough information to show you the utilization legend, the web application. So yeah. So now that we run traffic for a while, you see it will display the utilization. So you'll see at least between 30 and 50% of this in P6 and France. Again, you click on it and you get live information about the traffic. So it was 4 megs and so on. But that's pretty much it, a small section of LNet. And as I mentioned, the project is open source, so go ahead, fork it, use it, and if you have some feature requests, more than happy to look at that. That's pretty much it from my side. Let me just stop sharing.
Perfect. Thank you, Catalin. So we only have time for one normally sized question, or maybe 2 quick questions. So if you want to ask a question, either post it on the chat or raise your hand, and we'll take the the first people that will raise the hand, and then you'll have to unmute yourself. So both options. If we don't have time to go through the questions now, we will have to basically ask the questions at the end. I really like the latest version. I don't think I've seen the latest version, and I saw 2 features that are very good.
Thank you.
Okay. Any questions? If there are no questions now, I mean, we can always ask questions at the end.
I have one question, Dario here. You
it.
mentioned support SNMP and telemetry. What SNMP model support?
So on SNMP, it's version 2 and version 3, and it's used as a collector. For telemetry, it's up to the operator. However, they choose to collect the telemetry, and some of the people are using Juniper native telemetry. Some of them are using OpenConfig. So it's up to them.
Okay, thanks.
Sure.
Perfect, thank you. Okay, we'll have to move on for now, and we'll go back to the question session at the end. Thank you, Catalin, for the demo and for the presentation. And we will quickly go to Jeremy. Jeremy, I'll let you have the stage, please, if you want to give a short intro about yourself. And I understand that you had a presentation. It was with Kubernetes, but I think it's containers in general. So I'll let you explain.
So my name is Jeremy White. I'm a managing consultant for Network to Code. My background is from doing a lot of network automation at large oil and gas companies. So I've dealt with a lot of network automation at scale, especially whenever you're developing a network automation platform that is multi-tenanted. When you're in these large Fortune 500 companies, you might have 10 network teams that all have separate focuses or separate subcategories, versus at a smaller company when you're managing sub 500 devices, where all of your network teams are one single tenant. And I'll get into a little bit more of this a little bit later on why that comes into play. But Network to Code, we are a startup that is based out of New York. We are focused on open source network automation that's vendor agnostic and tool agnostic. So it doesn't really matter the flavor of networking, and whatever the tool sets is, we're able to adapt and build solutions around it. So today's presentation is on scaling network automation with containers. The demonstration that I have is using a Docker container that is being done with just a local Docker deployment. It was originally going to be done with Kubernetes deployment, but I got a little too ambitious with trying to set up Kubernetes on Raspberry Pis and build images correctly and have all of that doing exactly how I wanted. It took a little bit more time than I expected. So for today, so why containers? What's the value add with containers? We get repeatability. We get we reduce the likelihood of job collisions. We're able to publish what we know is actually going to work, and we can scale, and we can scale very intelligently with containers. And there's multiple different ways that we can scale. And then we're also going to go through a GitLab pipeline demo. And so the demo, I'll show the full stack later, but I'm actually running a community edition of GitLab in my local home network. And the whole stack is deployed locally, and so I'll dive into that a little bit more in just a little bit. So why containers? The biggest thing for me is about repeatability. There's no longer this case of, but the script worked on my PC or the script worked on this server. So the concept of going to a remote machine or running an Ansible playbook or a Python script locally, and then trying to port that same exact item to a remote device or to someone else's machine. There's no longer the concept, well, it worked here, but it doesn't work there, and having to troubleshoot what the differences are. By doing this with containers, we're able to remove host dependencies, and we're not having to worry about it. It could be something as simple as a Python library that has a version discrepancy between two separate tenants. And when I say two separate tenants, this could be network versus network security, or this could be something that's more disparate as a platform being network versus server automation. And containers give us the ability to be able to port that same exact workflow from site A to site B to site C. There's a fast food restaurant in the US that's doing some really interesting things about deploying edge compute nodes at their local restaurants and running actual edge computing for managing their network at the physical restaurant. So the idea of being able to have these very distributed
workflow execution is really kind of awesome. Reduce the chance of job collision. So this is one thing that I've run into with Ansible Tower, AWX, also with Rundeck, the ability of having, if you have a multi-tenanted platform, you have multiple different teams. I run a specific time that I ran into this is there was a requirement for the network team to be on a certain revision of Ansible for some package. Can't remember what it was, but then the server infrastructure team that were wanting to use I can't remember what the connection method was, but to be able to manage Windows servers had a conflicting dependency on an Ansible library. So because they were on conflicting Ansible package dependencies, someone upgraded the virtual environment on the host that Ansible Tower was running. So I can't remember who upgraded it first, but it was a battle for like a couple days before we figured out what was still going. One team would upgrade it and their stuff would work, and then someone else would say, hey, my stuff's not working. Oh, wait, it's the wrong version, so let me downgrade it. And then it was a struggle back and forth. And that's not necessarily just isolated to Python libraries. This could also be underlying system packages and so on. This can also happen with, especially if you're running multiple jobs at the same time and you're writing files to the file system. If you're, like, for instance, with Ansible Tower, they do a really great job for doing job isolation, doing these temporary directories, and they've really thought that out very well. But not all orchestrators have that firm guardrails when it comes to job isolation. So there is still the possibility of having two identical jobs that are running just a little bit different, writing to the same exact file system and overwriting each other's outputs, depending on how the automation is built and what the file system directory is and everything. And also, there's this is one of the things that I've run into with some systems is the idea of blocking. So whenever you're scaling, if you're having to worry about a job blocking the next job, because it is host like CPU constraints or dependency constraints or whatever it may be. An example of this would be like with the Ansible Tower. If you have all of your projects tied to one SEM, and then within that SEM, you have the option to update on launch. So what happens whenever you have multiple jobs come in, that SEM update is becoming your blocker. For that every single job has to first do an update, execute its job, run through fruition, then the next SEM update happens, and then that job runs through to fruition. So it's by disaggregating where these are being executed and how they're being executed, you could potentially alleviate some of the blocking patterns that you may have with tools like Ansible or Rundeck or so on. This also gives us the ability to fully package a full end-to-end workflow in a functioning state. And we're able to publish it to where we say that on day one, we know it works. And as long as the underlying endpoint that we're reaching out to hasn't had any changes, that would be any breaking changes, on day 365, day 1000, or heck, if it's some of the Cisco 6509Es that I've seen them up for 13 years. So as long as that stuff hasn't changed from day one to day 13 year, the individual job that was originally published could, in theory, work exactly the same 13 years later. And there's also, you remove the concept of having to worry about host dependencies and someone else coming in and fighting with you, like I mentioned previously. The Windows team and the network team at a previous employer that are having conflicting Ansible packages. And for how you're scaling and deploying the containers, you have the ability to be able to deploy the containers as a job with a manifest straight to Kubernetes. You can deploy them and orchestrate them with essentially like compose files on Docker Swarm. You could have your CI pipeline installed directly on a Docker host, be it Jenkins or GitLab Runner, which we're demoing GitLab Runner. Or you can also have the Docker CLI installed, but using a remote context for Docker. And then another thing to keep in mind when we're considering scaling, so although we may have removed the blocking mechanism from, let's say, Ansible Tower that I spoke about previously, we could be potentially introducing another blocking mechanism. So within the GitLab Runner, the default concurrent execution is 1. So there can only be one job through the pipeline at a time. So you can either expand that or GitLab Runner has the ability to do auto registration and deployment with Kubernetes. So in theory, you could spin up and spin down as many runners as you need to be able to orchestrate all of your jobs within Kubernetes. All right, so the GitLab pipeline. So today's demo, this is going to be so super simple and not realistic, not anything that you would ever do in production. I manage my local home network. I have a Juniper EX2300 12-port PoE switch. I have a simple playbook that the playbook and all the host files for this demonstration are all stored in a GitLab repository. So we're going to be managing the VLANs and the layer 2 interfaces. And we're going to be able to see that by making a change to the declarative config, it'll trigger a pipeline within GitLab, which will then cause the GitLab runner to rebuild the container and then execute the container and push the updated configuration to the network device. And so just a little quick snippet of the host vars for the device we're going to be touching. It's EX, that's the host name of my, my layer 2 switch. This is just a subset of it. And this is just the minimal set of vars that we need to be able to execute the actual demonstration today. I'm not going through and managing the full device with infrastructure as code for today's demo. This is just meant to be kind of what the possibilities with managing workflows in Docker. And then for the pipeline that's running, we are using GitLab Runner. It's registered in GitLab as a shell executor. And this is basically a no frills attached demonstration. It's just essentially connecting to the Docker socket on a remote device. It's going to log into GitHub, I'm sorry, not GitHub, Docker Hub, so that I can pull down my private Docker Hub private Docker Hub image that I've created. And it's going to then rebuild my local image and then run the automation on that individual device. The actual Docker engine that's running all of this is a Raspberry Pi 4. So it's the idea of having these very low-cost compute nodes that you can distribute globally and be able to execute globally and not have to worry about spending a tremendous amount of money on hardware infrastructure is really kind of interesting, especially when you look at solutions like, I believe, Juniper, Arista, and Cisco are starting to deploy or give you the ability to deploy containers on certain next-gen networking devices for the edge networks. And then for being able to track the pipeline, you have the ability to go back and see all the historical metrics and everything that happened within the historical executions of the pipeline. Where you can see that I failed twice and I passed, and you can kind of dive into that and see what's the actual output. All right, so we have a demo. Demo God's already not smiling down on me. I just got notification on my headphones that my battery is low, so hopefully if it switches to my external speakers, it won't be too bad. Let's go over and take a look. So here's my simple repository. I've got my playbook here. The main Docker file for the base image which is what I'm storing in the public Docker Hub as a private repo. It's essentially just doing a couple installs of prereqs and then doing an install of Ansible and NC client. The reason why I do this as a base image is this stuff is not going to change very often. And because I'm building this on an ARM architecture, it takes a tremendously longer amount of time to be able to build and compile versus being able to do this on an x86 platform. So I instead of having to worry about 30 minutes for a build cycle for each execution, I pre-build all my base dependencies that are never going to change or change very infrequently and publish that to Docker Hub. Then we come over and we take a look at the Docker image that we're actually building for the workflow itself. You can see we're sourcing from the base image. We are going to be switching to our working directory, doing a installation of some of an Ansible collection, copying in some files, and we're setting the entry point as Ansible playbook. So if we come back and we look at the GitLab CI, which I showed in the presentation, you'll see that we first make sure that we connect to the remote context. We log into Docker Hub, we build our image, and then we're going to run our image. And now, and if we look here in the terminal, we also see that gig Ethernet 0011, the VLAN member is the VLAN named LAN. So I look at my host vars and I scroll up, My declarative VLAN is VLAN ID 100 and has a description of standard LAN VLAN. So what we're actually going to do is I'm going to grab the voice VLAN down here, add that there, walk the different shell session, go to the git status. So we can see that I have one file to change, which is my host vars file. And I'm doing something that's very terrible, very sacrilege, but I'm going to commit straight to master. This is my home network. This is not something I'd ever do in production. Always want to be doing branching, merging strategies and having additional CI testing within your pipeline, but just to show the power of managing your network with Docker containers, managing the workflows and using Docker containers and the power of that. All right, so we'll do a git push origin master. So now if we come over and we take a look within GitLab, we're going to go back here. We'll see that we have a job that just came in 15 seconds ago. It's already starting to be executed. And I just want to make sure, before I jump over and go back to the presentation, because this takes about 3 minutes to run, I wanted to make sure that this, it looks like it's executing correctly. I sometimes have difficulties hitting this specific Raspberry Pi, which that's exactly what I was expecting to happen. So let's just retry it. And this should go through this time. All right, while we're waiting on that, I can jump back over to the presentation because I was anticipating problems because demo gods never smile on me. So essentially the demo stack today, like I mentioned, we're using GitLab and GitLab Runner. This is running inside of containers on a Linux virtual machine. I'm directly interacting with GitLab. The GitLab Runner is attached to a message bus on the GitLab instance, waiting for new jobs to come in. The GitLab Runner is tagged as Docker. As soon as a job is placed into the queue that has the tag of Docker, it's immediately going to pull it and start executing the scripts that are specified in the GitLab CI.yaml. The remote Docker daemon is actually running on a Raspberry Pi 4. And the network device that we are going to be interacting with today is going to be a Juniper EX2300. So using that for my PoE switch to be able to drive everything within my house. And so the pre-change, like you saw on the VS Code output, I had this the access VLAN set as LAN, and then post-change we changed it to voice VLAN. And once everything is completed, we'll see that the output from the playbook is going to show that the configure VLANs is going to come back as okay, and that the L2 interface is going to come back as changed. Because I didn't make any changes to the VLAN configuration. I only made changes to the L2 interface configuration. Then at the end, we should be able to see that the pipeline is passed and everything is good with the world. So now let's jump back over and see. Yep, so here we go. Like I said, sometimes it has difficulty connecting to that Raspberry Pi. That's one of the few things that's not hardwired on wireless. So we can see that we're starting from the base image that I published to Docker Hub. We're going to be we're going to be changing directory to user source app. We're going to do an install of the collection. We're going to copy our files in, and then we're going to set the entry point as Ansible playbook. So everything looks good to go there, and the playbook is actually running right now. So it's going to it takes about 3 minutes for this to fully run, so we're probably about another minute to 2 from it completing. While I'm waiting on that, does anyone have any questions? So there's a question in the chat. With our Ansible setup, we have all of our playbooks, roles, and inventory in one GitLab project. With this sort of setup, how would it be best, assuming it's possible to define which playbook should run based off of the changes to group bars or host elements? This would have to go into how you're actually setting up and managing your network itself. In theory, since Ansible is idempotent, if I had the proper compute power and I was not concerned about someone making a mistake or anything like that, I would in theory be perfectly fine with once an hour, once a day, having the CI actually just go out and smash and enforce compliance on the whole entire network. That gives it the ability to enforce your intended state versus actual state, so that if you have someone that wants to be a CLI hero and log into the device and make a change on the CLI that's not in line with what's being tracked in the source of truth, it reinforces the source of truth. It makes them have to go back and update the source of truth. Yes, there are. I've worked at previous Fortune 500 companies that do actual enforcement on their production networks. Now, the level of enforcement is going to depend greatly on company to company. You'll see a lot of times, a lot of the enforcement is being driven based off of compliance and what their compliance documents are written off of. So if your AAA configuration must look exactly like this, I'm sure AAA is going to be absolutely enforced. But if your host name standardization is not part of a compliance report, then it's not going to be enforced. Cool. You see that everything's completed, everything is successful as expected.
Yeah, just to let you know that we will have to wrap it up quite soon, so we can get some questions. Jeremy, was that the end, or do you have anything else to add?
Nope, that was it. This
Perfect. Okay.
End of the presentation.
Thank you very much. Thank you, and you've handled the questions that came in the chat quite well. So thank you for doing that. I know someone that will be trying this quite soon, so I took this out of my backpack. I've got the Raspberry Pi, so I definitely need to try the same thing. So yeah, thanks for the demo. We do have again time for maybe two short questions before we move to the panel, because we are running out of time quite quickly. So if you want to raise your hand, I think we already have one question in the chat.
So yeah, I see there's a question in the chat pertaining how do you manage having intended state coming from multiple different sources of truth. So in theory, you'd have an authoritative source of truth for a specific data domain, and that does not necessarily mean that all device facts are going to come from the same exact authoritative source of truth. So the perfect example in the chat is having some facts that come in from NetBox and some facts that come in from Git. What I've done in the past is I've created NetBox plugins that will allow you to aggregate source of truth data from a Git repository into a custom view within NetBox, where it's coming back in one API payload. Another option is building it into the actual workflow itself, that before you actually push configuration, you either do a dynamic inventory from NetBox, then go out to Git to get the information, or vice versa, where the data is buried together within the workflow.
Perfect, thank you. I think I also have a question from Simon. If I think Raspberry Pi Zero has enough grant, yeah, most likely not to run a container. You can probably run some SSH commands and maybe Ansible, but yeah, definitely not. I'll need to be honest, I'll need to find my my full-sized Raspberry Pi. I haven't actually used it for over a year, which is a shame, but yeah, definitely something I have to test after Jeremy's demo.
And the Pi Zero wireless can do Docker containers. What you run into a lot with them, especially with C compiling and GCC compiling, is some of the Python dependencies. Whenever you're installing on an ARM-based architecture, the actual PyPI libraries are not coming down as a wheel format, so they have to be compiled locally. And so it just gets very painful, and especially on Pi 3 and earlier, you're dealing with a very constrained set of RAM. So you'll very quickly go into swap, or you're very quickly essentially just freeze and not be able to proceed any further. That was part of what my issues with Kubernetes was trying to compile all of this on a Pi 3 instead of one of my Pi 4s. And that was where I ran into issues.
Yeah, good point. I think the Raspberry Pi Zero only has 512 megs of RAM. Well, thank you, and yeah, we're gonna have to move on to the panel because we are running out of time, and yeah, the panel format will be similar to what we had in when we had the meetups in person. Obviously, there were some questions which have been sent already when people registered for the meetup. So we're going to try to go through some of the questions there. On the panel tonight, we have Martin Henson, who's well, first of all, a good friend of mine, but also he's an enterprise systems architect focused on network automation. Martin, I already have a question which has been sent, and it's just perfect for you. And we also have Stuart, Catalin, and Jeremy. So at this point, if you have any questions, or whether it was related to the presentations that we've had, or some more generic questions, feel free to raise your hand, because if you raise your hand, we're going to take the questions in the order that that you've basically registered your interest. I do want to begin this with one of the questions that has been sent when someone registered. Martin, this is your first session, but this question has been asked before. It's always a very hot topic, and I know that this will be something up your alley. And also, if you want to just give a short intro about yourself, but the question sounds: how do you get director or senior leadership buy-in to embrace network automation?
Well, that's a great question. Funny enough, Stu was on the call earlier today, and we've actually experienced this. I think to so who I am. So yes, I'm Martin Henson. Yes, I work for Cisco. I fell into network automation through my relationship with Paul and others that are on this call. Actually, some of those are the people I've actually engaged with externally, and it's been a bit of a roller coaster because I've come off one train track onto another. So to answer the question on how do you get senior leadership and management to move over, actually, the first thing is culture. There's a massive cultural shift that I'm seeing within every organisation I talk to. They don't know how to consume it, and the biggest thing is a fear factor. And the fear factor isn't loss of jobs, but the fear factor is how do we trust what automation offers? So the lowest barrier to entry is for any network engineers or network architects that are building up strategies is low hanging fruit, always go simple, and always go low risk. That would be the answer to that question. Hopefully, I've answered it very quickly due to time.
Yeah, definitely. Thank you for that. I think we have some questions that came in via the chat. I think this one is for Jeremy. Jeremy, do you see a lot of using NetBrain as Ansible source of truth, or rather a bunch of variables defined in the host vars or group vars?
I have not seen as many customers use NetBrain. If you're referring to NetBox, I do see a very large adoption of NetBox for source of truth data. But even at that, there is not every single aspect of device configuration has a place inside a NetBox. So this can either be augmented through the combination NetBox and Git for a certain for certain attributes, custom fields, which are very costly, big context, or extending the actual NetBox framework with a NetBox plugin to augment and create new data models that have the additional attributes that may not be there out of the box.
Perfect, thank you. And a very interesting question. I think this was probably one of the first questions that that came in. I don't know who's going to pick this up because it touches so many. I think everyone is suited to basically answer this. But yeah, what are the challenges if we got a lock-in because of because of tools or network automation activities? So what are the challenges if we got a lock-in because of tools or network automation activities?
So, Paul, is that based on vendor? Is that what you're referring to?
It doesn't say, but it tends to be around, what if you have a vendor, but I think if you're open source, you're probably, you can probably find it easier to move to something else, but I think you'll probably find a similar challenge there as well. So, of course, it's from organization to organization, but yeah, well, who wants to go? Who wants to pick this up? Martin, yeah, go for it.
So very interesting. So another way to look at it is the economy of scale, right? So irrespective of the vendor, Cisco, Juniper, Arista, whatever, doesn't really matter. System controllers, that abstraction layer that takes the complexity southbound away and consuming those northbound intent APIs. So irrespective, it's just all about scale. If I've got, say, I don't know, 15,000 switches globally, and I want to build a data model to consume or utilize the APIs in those switches, right? It's going to be massive. If I abstract it out with a system controller, or I use something, as Catalin mentioned, around open config, then you can consume, any vendor because you're consuming a standard API and data model. So it's a really good question, and there's no real direct answer to it. But from our perspective, from Cisco's strategy, system controllers are where we are focusing the business on.
Perfect. Thank you for that. And I think a question which probably tailors quite well with Catalin's background. What is the most commonly way to offer your network automation service system or scripts to your clients? And the clients could be IT teams, NOC, etc. Is it simple script by using CLI in an SSH host, graphical interface, homemade? Is it IT service catalog like ServiceNow or other, etc.? Yeah, I mean, your presentation probably covered some of these, but yeah, do you want to take this? I think you're on mute. No. There's no sound.
I can chip in if Catalin's can't.
No, it doesn't work. Few glitches. Do you want to take this, Stuart, until to see if Catalin can sort out the sound?
Yeah, so I mean, I actually think that question lends very well to the containers session as well, and how you actually start to package these things up. Everyone's going to have a different way in how they want to consume, be through ServiceNow, be through they just want to do it through the CLI, and they've got their own environment. If you can make it as easy as someone can to go and package things up and say, right, I know how I'm going to do this, document well, put it into a container, just making it frictionless as possible, I think, because everyone's going to have a different way, as long as you can kind of say, well, listen, and then probably after about 10 times, you'll then start to see some patterns. So that'd be my thinking anyway.
One thing I think to that is looking at the actual target audience. So a lot of clients that I've worked with, there's not just one target audience for the automated workflows. You may have a non-network team consuming a network automated workflow, so they need a very curated, simplified form. So that would absolutely go straight into something like ServiceNow as a service catalog item. Whereas your more advanced power users could be going straight to your automation engine, which like Rundeck or Ansible Tower, whatever it may be. And then for one-off changes that don't necessarily make sense to publish somewhere else, that's where it would fall down into a CLI operation.
Hear me now?
Yeah, we can.
Oh, finally. Sorry, my PC got some issues. So yeah, well, what Jeremy mentioned, I think that's key as well. So fallback should be always an option there. I would say web GUI is most usable for various internal customers. So just that in that regard.
Perfect. Thanks for that. I think the network connection is playing up there, but yeah, I think we only have time for one more question because we're up to 7:30, and we promise we're going to have a session which is going to last 1 hour and a half. So let's have a look if we have anything in the chat, or if someone in the audience wants to ask a question, just feel free. If you want to unmute yourself.
Hey guys, Danny again. Yeah, thank you so much for everything. It was really good. I have a very quick one for Jeremy, because it's a good idea. I've never really thought about that in terms of using the CI/CD pipeline with GitLab to enforce. How scalable is that? Have you done that in production? Is that a good method?
It's going to be dependent on what it's consuming by the underlying backend. It can be very scalable if you have the appropriate amount of runners, you have a fully distributed system, and you're able to properly architect and deploy your whenever you're pushing your manifest, so that they're deployed as close to the endpoints as possible. To me, it makes Ansible a lot more scalable when you're having the 1,000 or 10,000 or 20,000 node count.
Okay, but the real life experience it works, yeah? I mean, on that scale.
Yep.
Okay, thank you.
Perfect. Thanks for that. Are there any more questions? If not, we're going to try to wrap it up. Thomas, go for it.
Yeah, I was just going to say, so wrapping up, firstly, I wanted on behalf of everybody else to say thank you to Paul for putting tonight together. Paul did a lot to do this. In fact, I frankly did most of it. And I know he's not mentioned on the slide, so I thought we should say thank you to Paul to do that. But I also just wanted to say that obviously we would like to try and do this again. If people have suggestions for topics or people they'd like to see speak to us, particularly as at the moment we can get people from pretty much anywhere, and we don't have to fly them to London, do reach out and let us know.
Yeah, absolutely. And yeah, thank you, Thomas. Big thank you, because massive help for this session. So we're gonna try to wrap it up there. Just a reminder that this meetup is of course run by people that also have day jobs. We go into migrations, we work long weekends, we don't have the amount of time to actually allocate in organizing this session. But these sessions have been such a great way to basically keep up with the with what's happening on the network automation, but also over time we met familiar faces, a lot of co-workers, ex-workers, friends that actually meet at these sessions, and definitely we will try to keep this hopefully monthly. We will see how many migrations and how many projects we will be involved in over the past few weeks. But yeah, definitely if you're interested in presenting, or if you want to sponsor this session, or if you have an idea that you want discussed, feel free to reach out to us. Either LinkedIn, if you know someone that is actually helping organize this session, reach out to us. Just pick up a name, reach out to Thomas or to me, or just use the email address that it was in the it's up on the screen now. But yeah, thank you for taking the time, and thank you to the presenters. Thank you, Martin, for taking the time to be here tonight. And we'll try to do this again quite soon, hopefully in the second week of December. But we'll see how it goes. Enjoy the rest of the evening, and I'll publish the recording as soon as it's available.
Thank you very much.
Oh,
Thank you.
Thank you.
Thank you.
Bye. Thanks, guys.
Paul, you can click stop recording.